All right, this is the continuation of our notes from class yesterday. We are looking at 2.2, that section. Remember, yours is all in one big packet, but we did not do the time series graph, so I want to finish that one up, and then I'll have a separate video for 2.3. So let's scroll down to kind of where we left off. We did the Pareto charts and the pie graphs in class together. And then if we look at the kind of definition of time series graph and how to create one of those. So it says a time series graph, the data are plotted in order of occurrence at regular intervals over a period of time. So what we're talking about there is that we are going to be using measurements of the same variable for the same subject taking at regular intervals over a period of time. So the basic example from the textbook was that they had distance in miles walked or jogged in 30 minutes, and they were tracking it over 20 weeks. So the first thing we'll do is draw and label our horizontal and vertical axes, mark the axes in equally spaced intervals, and list the time period in order on the horizontal axis. Label the graph with a title. So notice right here, we've kind of got, this was the information given. They've gotten it in 2 rows, but notice the weeks are across the top and the distance in miles was on the bottom for each of those. So our title is distance in miles walked or jogged in 30 minutes. The vertical axis is the distance in miles that we actually walked. And remember, we're tracking time series graph. The time we're tracking is on the bottom. So this was a 20-week tracking. So notice we have 20 equally spaced marks, and notice here we have a little break because we want to zoom in. Nobody walked less than 1 mile or jogged less than 1 mile, but we never got higher than 3. So we kind of, instead of having our graph have a big gap between 0 to 1, we use that little graph break, and then we have 1, 2, and 3. So notice this is just plotting ordered pairs and connecting the dots as we go as a line graph. So that's all a time series graph is. The heights of your data points are your measurements, and remember the time is your X values. So we plotted those data points, connected them, and pretty much everything is pretty self-explanatory on this type of problem, but we're going to do one together. So it says create a time series graph using the data from exercise 14 in our statistics textbooks. I've just copied it here so we didn't have to look that up. We'll draw and label the horizontal and vertical axes, mark the axes in equally spaced intervals, and list the time period in order on the horizontal axis. Label the graph with a title. So all the things we expect that we needed to do for a time series graph. So it says, how does the average height for boys change as boys get older? So they've given us, it looks like age in years. Most of the time it was a 1-year jump, but that very first part was at 6 months to a year. So in my old ink version of the notes, I actually used 0.5 as its own mark. I didn't quite equally space it, but we're going to do it more what we said that we should do. We're going to equally space it. So we're going to have a 0, 1 through 14 as our time at the bottom for the years, and then we'll just of course have to plot that point for 6 months or 0.5 of a year. We'll have to plot that kind of in between. Okay, and then the height is in inches, so those are going to be our vertical axis points. So let's go ahead and label everything we need. So if we look at our graph, we're going to be putting years at the bottom. This is a time series graph of, we had the heights of average heights for boys. I think that's how I'm going to title it. Average height of boys. And then remember over here, this is going to be our height in the inches. Since they did give us the unit of measure, we should reference that. Okay, so we're going to start this with a 0, and then we need to go up to 14 years old. So evenly spaced. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So just about, not quite perfect because I don't have a ruler, but just about. Now, we don't want to go from 0 to 26 and try to actually mark those because there's quite a big jump. This is only going from 26 up to a max of 62. So I kind of chose to make a little line graph break right here. And then I actually started marking mine at 24 and counting by fours. And that's because I'll hit 60 and 64, and those are kind of easy to plot those points because some of them are going to fall in between. All right, so I had a person stop by, sorry, real quick for that. So let me continue where we were at. So I decided I was going to count by 6, I think, or no, by 4. And that's just to make some of the numbers pop up nicely as we're heading up to the 62. So this would be 28, and then 32, 36, and then 40, 44, 48, 52, 56, 60, and 64. Okay, so at a half of a year, we were at 26 for the height. So that's between 24 and 28, halfway, and we're at the half year mark. Then we have at 1, we're at 29, so that's just a little bit above 28. We can go ahead and connect these as we go. At 2, we're at 33, so that's just a little bit above 32. At 3, we're at 36, so that's right on that mark. At 4, we're at 39, so just a little bit above or below 40. Notice we're just connecting the segments as we go. At 5, we're at 42, which is about halfway between the 40 and the 44. At 6, we're at 45, so just a little bit above the 44 mark. At 7, we're at 47, just a tiny bit above, or below, I should say, the 48. At 8, we're at 50, so halfway between 48 and 52, and I'm kind of eyeballing these as we are getting further away. At 9, we're at 52. That one should have been a little further over. And at 10, we're at 54. At 11, we're at 58. At 12, oh, sorry, I think I skipped one. At 10, we were at 54. At 11, we were at 56. At 12, we were at 58. Yeah, sorry. And then at 13, we were at 60. And at 14, we're at 62. So not quite a perfect linear pattern. We can see there is kind of just an overall increase because usually people don't shrink as they grow. But that is a time series graph for this group of boys. So let's see. Now, the last part of this section, because like I said, I'm going to just post the ink for the U-Try parts, and you can look at those and try them on your own, see if you did okay. The bar graphs are useful for quantitative or qualitative data. With qualitative data, the frequency or percentage of occurrence can be displayed. With quantitative data, the measurement itself can be displayed, as was done in the bar graph showing life expectancy. Watch that the measurement scale is consistent or that a jump scale squiggle is used. Pareto charts identify the frequency of an event or categories in decreasing order of frequency of occurrence. That's really just for nominal data a lot of the times. Circle graphs display how a total is dispersed into several categories. The circle graph is very appropriate for the qualitative data or any data for which percentage of occurrence makes sense. Circle graphs are most effective when the number of categories or wedges is 10 or fewer. The more wedges you have, the more complicated it is to even see what the circle graph is doing. A time series graph displays how data changes over time. It's best if the units of time are consistent in a given graph. For instance, measurement taken every day should not be mixed on the same graph with data taken every week. And then for any graph, provide your title, provide your title, label the axes, and identify units of measure. And then don't let artwork or skewed perspectives cloud the clarity of the information displayed. Remember, we looked at that first clustered bar graph kind of comparison and saw how just changing our scale can change our perspective or cloud what we think the information is displaying. And I think, let's see. Yep, the next part is the U-Try. So I'll post, like I said, the ink notes for all of that. And I'm going to make the video now on the stem and leaf plots.